Hello students, welcome back to my channel. Today I am going to discuss about some formulas of the chapter Interference of Light of class 12. Firstly, I am telling about superposition principle. So what is superposition principle? The resultant displacement of a particle at any instant is the vector sum of the individual displacement caused to the particle by the two or more waves. Let y1 and y2 be the displacement of particle respectively at any instant caused by the two waves. Then the resultant displacement of the particle at that instant is given by vector y equal to vector y1 plus vector y2. Superposition may be constructive or destructive. So what is constructive superposition? When two waves of same wavelengths superimpose on each other in phase. That is, crest of one wave falls on the crest of other wave, or trough of one wave falls on the trough of other wave, then the superposition is constructive. Destructive superposition. When two waves of same wavelength superimpose on each other out of phase, that is, crest of one wave falls on the trough of the other wave and vice versa, then the superposition is destructive. Next topic is coherent sources of light. Two sources of light are said to be coherent if they emit waves of same frequency or same wavelength and are either in phase or have a constant phase difference. Lasers are highly coherent sources of visible light. Coherent sources are generally obtained by deriving them from a single parent source. Two independent sources of light are not coherent sources of light. Now in this slide, we get to know about interference of light. So what is interference of light? The redistribution of light energy due to the superposition of two light waves from two coherent sources is called interference of light. Conditions for sustained interference of light. Number 1. The two sources of light should be coherent. Number 2. The waves emitted by the two sources should have same frequency. Number 3. The separation between the light sources should be as small as possible. Number 4. The distance of the screen from the two sources should be quite large. The interference phenomenon can take place in all waves. Interference of light shows that light behaves as wave. The phenomenon of interference in light was demonstrated by Thomas Young in 1801. This experiment established the wave nature of light. Now I am showing some formulas. Number 1. Amplitude of resultant wave due to interference of two waves is given by r equal to root over a1 square plus a2 square plus 2a1 a2 cos phi. Here phi equal to phase difference and a1 and a2 are the amplitude of the two waves respectively. If the phase difference phi equal to 0 degree, then the resultant amplitude will be maximum, and this maximum resultant amplitude equal to a1 plus a2. When phi equal to 180 degree, then resultant amplitude will be minimum, and this minimum resultant amplitude will be a1 minus a2. Intensity is directly proportional of the square of amplitude. Intensity of resultant wave due to interference of two waves is given by I equal to I1 plus I2 plus 2 root I1 I2 into cos phi. Here I1 and I2 are the intensities of two waves respectively. In this condition, the maximum intensity will be I max equal to root over I1 plus I2 whole square, and the minimum intensity will be I minimum equal to root I1 minus root I2 whole square. As the intensity is directly proportional to the square of the amplitude, so I max by I minimum equal to R max by R minimum whole square, or A1 plus A2 by A1 minus A2 whole square, or root I1 plus root I2 by root I1 minus root I2 whole square. At the point where the resultant intensity of light is maximum, the interference is said to be constructive. At the point where the resultant intensity of light is minimum, the interference is said to be destructive. There is a relation between phase difference and path difference. Phase difference equal to 2 pi by lambda into path difference. For constructive interference, phase difference will be 2m pi and path difference will be m lambda, where m equal to 0, 1, 2, 3, etc. For destructive interference, phase difference will be 2m minus 1 into pi and path difference equal to 2m minus 1 into lambda by 2. Here m equal to 1, 2, 3, etc. Here lambda equal to wavelength of the light. There is a relation between intensity of light of source and the width of the source. Let W1 and W2 be the widths of two narrow sources S1 and S2. Therefore, the intensity of light of these sources B, I1 is directly proportional to W1 and I2 is directly proportional to W2. That means I1 by I2 is equal to W1 by W2. Now I am discussing about Young's double slit experiment. Let two coherent sources of light S1 and S2 separated by a distance d be derived from a source S. Here O is the position of central bright fringe. Dark and bright bands in the interference pattern are called interference fringes. Let capital D be the distance between the screen and the plane of slits. Now I am showing some formulas which is based on Young's double slit experiment. The separation of nth order of bright fringe from central fringe is given by x suffix m equal to m d lambda by small d. Here m equal to 0, 1, 2, 3, etc. Putting m equal to 0 in this formula, we get the position of the central bright fringe. Putting m equal to 1 in this formula, we get the first bright fringe. Putting m equal to 2 in this formula, we get the second bright fringe. Again, the separation of nth order of dark fringe from central fringe is given by x suffix m dash equal to m minus half into capital D lambda by small d. Here m equal to 1, 2, 3, etc. Putting m equal to 1 in this formula, we get the position of the first dark fringe. Similarly, putting m equal to 2 in this formula, we get the position of the second dark fringe. Putting m equal to 3 in this formula, we get the position of the third dark fringe. The separation between two consecutive bright fringe or dark fringe is called fringe width. The mathematical expression of fringe width is beta equal to capital D lambda by small d. The expression of angular fringe width is theta equal to lambda by small d. If the whole apparatus is immersed in a liquid of refractive index small n, then fringe width in the liquid is beta suffix w equal to beta by n. In this slide, I am showing intensity distribution curve of Young's double slit fringes.